Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we are successfully finished the 15 lectures, right? So in a previous lecture that we have discussed about example problems based upon man rain problems. Okay, we have discussed 7 different types of example problems in that class, right? So in today's lecture that we are going to discuss about one of the important concept. So this concept is also depends upon relative velocity concept, and the concept is motion of a boat in the line of reverse flow. Motion of a boat in the line of reverse flow. Okay, this concept is also depends upon concept of relative velocity. Concept of relative velocity. So we are going to discuss about a downstream. What is the meaning of downstream? What is the meaning of upstream? Okay, na? So time taken by the boat to cover downstream, time taken by the object to cover upstream. Okay, na? And at the end of the session, same some example problems that we are going to discuss in this lecture, right? So this is a small lecture. Maybe it takes a 30 to 35 minutes only. Okay. So shall we start the session? Okay. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the session? Okay. So what is the chapter going on? So the chapter is what? Motion in a plane. Motion in a plane. Okay. So this is the class number 16, right? So class number 16. And what is today's concept? Motion of a boat. Motion of a boat in the motion of a boat in the line of reverse flow. Reverse flow, not reverse, river. Okay, motion of a boat in the line of reverse flow. Okay, right. So our first concept on this topic is the boat. The boat is moving, moving in the direction, in the direction in the direction of reverse flow, the direction of reverse flow. So this is also called as a downstream. This is also called as what now? Downstream. Downstream is nothing but simply the object is moving in the direction of flow of river, of water, whatever it is. Okay, then it is called what? Downstream. That's it. Okay, right. Have a look. There is a river. Okay, here I am taking the river. So the river is flowing on the ground. The river is flowing or moving on the surface of the ground. So this is the direction of reverse flow. Okay, so this is the direction of reverse flow. The water is moving like this. La, 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 la. Okay, right. So I'm taking the velocity of river in this direction. Velocity of river is in this direction. So velocity of river with respect to what? With respect to ground, because the river is flowing on the surface of the ground. Are you getting? That's right. So whatever the velocity of river is there, that is velocity of river with respect to ground. Okay, sir. We are understood. Okay. Now there is a boat. Initially, at time t is equals to 0. Initially, at time t is equals to 0, the boat is at a point A. The boat is at a point A, and it is started moving in the direction of reverse flow. It is started moving in the direction of reverse flow. Only the thing you have to remember, whenever the boat is moving in the direction of reverse flow, then the velocity of the boat must and should be with respect to ground. Velocity of boat with respect to ground you should take when it is moving in the direction of reverse flow. It is moving in the direction of reverse flow. So whatever the velocity of boat is there, that is velocity of boat with respect to ground, and it is started moving. Okay, after some time t. After some time t, the boat is at this point. The boat is at this point. Let us say this is a point B. So this is what, ma? Point B. Okay. So now the boat is moving in the direction of reverse flow. Velocity of boat with respect to ground. So now the distance covered by this boat, let us say D. D be the distance covered by the boat when it is moving in the direction of reverse flow. Okay. Now simply I wanted to find out velocity of boat with respect to river. Velocity of boat with respect to river. So that is equals to velocity of boat minus velocity of river. Velocity of boat minus velocity of river with respect to ground. With respect to ground. So VBR is equals to VBG minus VRG. Okay. So from this condition, I am going to write the equation for velocity of boat with respect to ground. Velocity of boat with respect to ground. If this term comes to this side, it becomes plus VRG. That's it. Okay. Say this is the equation number capital A. Are you getting any doubts? Simple concept. Slowly I am explaining. Are you understood? Okay. Right. Now I want to find the time taken by the boat to cover distance d in case of downstream. So in case of downstream, the time taken by the boat to cover distance d. So time t is nothing but what ma? Simply distance by velocity. Time is nothing but what? Distance by velocity. So what is the distance covered by the boat? D. What is the velocity of the boat? Velocity of boat with respect to ground. So time taken by the boat to cover distance d in case of downstream is equals to distance by velocity of boat with respect to ground is equals to velocity of boat with respect to river plus velocity of river with respect to ground. That's it. हो गया एक concept complete हो गया. Okay, say this is equation number B, capital B. Are you getting any difficulties there? Simple concept na? Okay. So case 2. So in a case 2, if the boat if the boat is moving if the boat is moving in opposite opposite direction to the direction of reverse flow. Direction of reverse flow. So it is also called as upstream. It is also called as upstream. Okay, so what is the meaning of upstream? If any object, simply if any object is moving in opposite direction to the flow of river or water, whatever it is. Okay, so if the object is moving in the direction of reverse flow, water flow, then it is called a downstream. Whenever the object is moving in opposite direction to the flow of the river, flow of the water, then it is called what? Upstream. Opposite, upstream. Same direction, downstream. That's it. Okay, right, have a look. Here I am going to draw the diagram. So here I am taking the ground. So this is what? Ground. Same, the water is flowing in this direction. La 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 la. Okay. Right. Geo done done done. Okay now. So now the velocity of water is moving in this direction. So velocity of water with respect to ground is in this direction. Okay. Now the boat initially at this point, let us say A be the initial point of boat. Now the boat is moving in opposite direction to the reverse flow. Velocity of boat is opposite to the reverse flow. Now what we have to take here? Velocity of boat with respect to water or river. Velocity of boat with respect to river you have to take. So this is the only difference between downstream and upstream. So in case of downstream, the boat is moving in the direction of reverse flow. That's why here I am taking velocity of boat with respect to ground. In this case, the boat is moving in opposite direction to the velocity of reverse flow, water flow or reverse flow, whatever it is now. Okay, so that's why I'm taking velocity of boat with respect to water, opposite velocity of boat with respect to river, same direction velocity of boat with respect to ground. That's it. So after some time t, the new position of the boat is this is the new position of the boat. Let us say this is d. So now the velocity of boat with respect to river is in this direction and the distance covered by the boat, let us say d. Okay, so now what we have to find? We have to find velocity of boat with respect to river. Velocity of boat with respect to river. So that is velocity of boat minus velocity of river. In a simple case, velocity of boat with respect to river is equals to velocity of boat minus velocity of river. With respect to what? With respect to ground. Okay. Now have a look. The velocity of boat with respect to river is in this direction, and the velocity of river with respect to ground is in this direction. These two are opposite to each other. These two are what, ma? Opposite to each other. Have a look. Velocity of boat with respect to river, velocity of river with respect to ground, opposite to each other. That's why here I am taking negative sign. Okay. So velocity of boat with respect to river is equals to velocity of boat with respect to ground plus velocity of river with respect to ground. To find the time taken by the boat to cover distance d in case of upstream, what we need? We need the velocity of boat with respect to ground. So that is equals to velocity of boat with respect to river minus velocity of river with respect to ground. So let us say this is equation number C, A, B, C. Next, what we have to find? We have to find time taken by the boat to cover distance d in case of upstream. In case of upstream. So time is equals to what? Simply distance by velocity of boat with respect to ground. So time in case of upstream is equals to what, ma? What is the distance? db the distance covered by the boat. What is the velocity of boat with respect to ground? Velocity of boat with respect to river minus velocity of river with respect to ground. So this is the equation number D. You know, so D by VBR minus VRG. That's it. That's it. Time of downstream, time of upstream. Are you getting any difficulties there? Just one thing you should remember, that is whenever the boat is moving in the direction of the reverse flow. So whatever the velocity of boat is there, that is velocity of boat with respect to ground. Whenever the boat is moving in opposite direction to the reverse flow, then whatever the velocity of boat is there, that is with respect to river. This is the only difference between these two cases. Here you will get minus. Why you will get minus? The velocity of river with respect to ground is opposite. Negative sign shows opposite to velocity of boat with respect to river. So this is opposite to this. That's it. So remaining process is same. So time of downstream is equals to d by VBR plus VRG. Time of upstream d by VBR minus VRG. Just only minus is different. Okay. Any difficulties there? Simple concept now. Are you understood? Okay, sir. Right. Note number 1 is time of downstream divided by time of upstream. That is equals to what is time of downstream? D by velocity of boat with respect to river plus velocity of river with respect to ground divided by time of upstream. So d by velocity of boat with respect to river minus velocity of river with respect to ground. D get cancelled out and this term went to numerator. So time of downstream by time of upstream is equals to velocity of boat with respect to river minus velocity of river with respect to ground divided by velocity of boat with respect to river plus velocity of river with respect to ground. So this is what the ratio of downstream to upstream, time taken by the object to cover downstream to upstream. Are you getting any difficulties there? So from these formulas I am just written ratio of time of downstream to time of upstream. That's it. Right, have a look. Note number 2. Note number 2. The engine if the engine of the boat is switched off suddenly. So then what happened? If the engine of the boat is switched off suddenly, then what happened? Have a look. The river is flowing in this direction. The river is flowing in this direction. Our boat is switched off suddenly. That means the velocity of the boat with respect to river. So that means what, ma? Velocity of boat with respect to river is equals to how much? 0. Because the engine of the boat is turned off. So we are moving on the surface of the water. On the surface of the water. Suddenly our boat is switched off. Our boat is switched off. Now river is seeing us. Hey, your velocity becomes 0 with respect to me. That means the velocity of boat with respect to water becomes 0 because it is at a rest with respect to river. Are you getting? Now what happened? Its velocity becomes 0, but the river has the velocity, and it is moving in this direction, Now the velocity of boat is zero. Now the velocity of boat is zero, and the river is moving in this direction. Then what happened? This boat is also moving on the surface of the water with the same velocity of river. With the same velocity of river. Are you getting? Any doubts? Easy concept, na? So if the engine of the boat is switched off, then the velocity of boat becomes zero with respect to river. So with respect to river, the boat is at a still condition. Okay, now it is at a constant position. Now the river has some velocity. Now the river has some velocity. So whatever the velocity with which the river flowing, with that much of velocity, the boat is also moves in the same direction of river's flow. If the river is moving in this direction, then the boat is also moves with the same velocity in that direction. If the river moves in this direction, then the boat is also moves in this direction with the same velocity of river. With the same velocity of river. Then, therefore, velocity of river with respect to ground is equals to velocity of boat with respect to ground. Are you getting any doubts? Okay. Now time taken by the boat to cover distance d. Now the time taken by the boat to cover distance d. So time is nothing but what? Distance by velocity. So distance by what is the velocity of the boat? Velocity of the boat is nothing but velocity of boat with respect to river. So velocity of the boat with respect to ground is nothing but what? Velocity of river with respect to ground. That's it. So this is the concept of motion of a boat in the line of reverse flow. Okay, na? So downstream, upstream. Time taken, time taken. Okay. If the boat is switched off suddenly, just you remember, velocity of boat with respect to river is equals to zero. Then with which much of velocity the river moves, with the same velocity the boat is also moves. That's it. That's it. Any difficulties there? Easy concept now? Right. Pause the video and write the concept. We will do the example problems now. Okay. Pause the video and write the concept. 3, 2, 1, go. Right. So I'm just bring the 3 example problems based on our concept. So have a look at what is the first example problem they are given. So a boat takes 4 hours upstream and 2 hours downstream for covering same distance. The ratio of velocity of boat to the water in river. So already we have the formulas for the upstream and downstream. So what is the formula for downstream? So downstream TD is equals to distance by velocity of boat with respect to river plus velocity of river with respect to ground. Okay, so what is the equation for upstream we have? So d by just place minus here. So velocity of boat with respect to river minus velocity of river with respect to ground. What is the downstream time they are given? 2 hours. What is the upstream time they are given? 4 hours. Just to substitute here. So downstream 2 hours, that is equals to d by VBR plus VRG. Okay, so bring this to this side. So 2 into VBR plus VRG, that is equals to D. Okay, so same thing we can do here. So what is time of upstream? So 4 hours, that is equals to distance by velocity of boat with respect to river minus velocity of river with respect to ground. Bring this term to this side. It becomes 4 into velocity of boat with respect to river minus velocity of river with respect to ground is equals to D. So have a look from the given question. So the distance is the same. The distance is same. So whatever the D we got here, this D and this D, distances are same. Just equate these two equations. So here we have 2 into VBR plus VRG, that is equals to, and just writing at the place of D. These two D's are same. Just equate these two equations. You will get 4 into VBR minus VRG. Are you getting? Okay. So just multiply with 2. 2 into VBR plus 2 into VRG, that is equals to 4 into VBR minus 4 into VRG. So bring all the VRGs to one side and VBRs to one side. So here 2 VBR is there. If 2 VBR went to this side, it becomes minus. Here minus 4 VRG is there. If it is comes to this side, it becomes plus. Have a look. So 2 VRG plus 4 VRG is equals to 4 VBR minus 2 VBR. So 2 plus 4, 6 VRG is equals to 4 minus 2, 2 VBR. So what they are asking? So the ratio of velocity of boat to the water in river. The ratio of velocity of boat. The ratio of velocity of boat to. So bring this term to this side. So VRG is equals to, and just bring this term to this side, it becomes VBR divided by VRG, the ratio of boat with respect to river divided by the velocity of river with respect to ground, river, water, whatever it is. Okay, right. So if we bring this term to this side, so it becomes VBR divided by VRG, and if 2 comes to this side, it becomes 6 by 2. So 2 ones are 2 threes are. So 3 is to 1. So what is our answer, man? 3 is to 1. Okay. Are you getting any difficulties there? Easy problem now? Okay, very good. Let's we solve that problem. Okay. Right. Have a look. A boat takes 4 hours to travel certain distance in a river in downstream. Okay. So the time taken by the body to travel in downstream, how much? 4 hours they are given. So we have the formula. Have a look solution. So downstream TD is equals to, what is the formula, ma? So distance divided by velocity of boat with respect to river plus velocity of river with respect to ground. So this is what the time taken by the body to travel in downstream. So what is the time of downstream they are given? 4 hours. So 4 is equals to distance by VBR plus VRG we have. Okay, sir, right. Next, what they are given? Are you able to see the board clearly? Okay, it is clear. Right. So next what they are given, and it takes 6 hours of time to travel the same distance in upstream. Same distance upstream. What is the time? 6 hours. So we have the formula for upstream. TU is equals to D by, just place minus here. So VBR minus VRG. What is the upstream time? 6 hours. 6 is equals to D by VBR minus VRG. So distance is the same according to the given question. They are said distance is same. Now what they are asking, have a look. The time taken by the boat to the same distance in still water. Okay. So the time taken by the boat to cover same distance in still water. Still water. Velocity of water with respect to ground is equals to how much? 0. Still water means velocity of water with respect to ground is 0. In general, we can write velocity of boat with respect to water or river. We can write velocity of boat with respect to ground minus velocity of water with respect to ground. Still water, they are saying what? It is a still water. In case of still water, velocity of water with respect to ground is 0. Then velocity of boat with respect to water is equals to velocity of boat with respect to ground. What we have to find? We have to time taken by the object to cover distance d in a still water. Time is nothing but distance by velocity. What is the velocity? Velocity of boat with respect to water or velocity of boat with respect to ground. So this is the formula we got. Okay. So just we have to find the distance. They are given d. We have to find t. So from these two equations we can find velocity of boat with respect to water or velocity of boat with respect to river. Amma, river is nothing but water. River is nothing but what? Water. Okay. Just solve these two equations and find velocity of boat with respect to water and substitute here. You will get the answer. Are you getting any doubts? I am going to solve the solution. So just pause the video and write this part. Pause the video and write this part. 3, 2, 1, go. Right. So from this, our final answer is what? Time t is equals to distance by velocity of boat with respect to water or river. We have to find this. So from these two equations, I'm just writing this equation as, so I'm just sending 4 to this side. It becomes d by 4. That is equals to, bring this term to this side. So VBR plus VRG. Okay. Next, bring this 6 to this side. It becomes d by 6 is equals to, bring this VBR minus VRG to this side. It becomes VBR minus VRG. Say this is equation number 1. This is equation number 2. Add. Just I'm adding equation 1 and 2. I'm just adding equation 1 and equation 2. It becomes d by 4 plus d by 6. That is equals to VBR plus VRG plus VBR minus VRG. Okay. So 4 by d is equals to VBR into VRG. So d by 6 is equals to VBR minus VRG. After getting these two equations, I'm just adding those two equations. I got like this. So here we have to take the LCM. 6 into d, 6d plus 4 into d, 4d. 6 4s are 24, that is equals to, so have a look, plus VRG minus VRG get cancelled out, VBR plus VBR, 2VBR, okay, 6 plus 4, 10D divided by 24, that is equals to 2VBR, okay, so have a look, 2 ones are 2 fives are, okay, so 5 by 24, 5 by 24 is equals to, just bring D to this side, it becomes VBR divided by D, okay. Now I'm just writing the reciprocal for this equation, that means D by VBR, D by VBR is equals to 24 by 5. Are you getting ma? And just written reciprocal for this equation, it becomes D by VBR is equals to 24 divided by 5. So D by VBR is nothing but what? Time. Are you getting? D by VBR is nothing but what? Whatever the time we are required, that time. So that is equals to 24 divided by 5. So 5 ones are 5 fours are 4 remains point 40, 4 eights are 40. So T is equals to 4.8 hours. Okay. So time taken by the body to move in a still water to cover the same distance, it takes 4.8 hours. Are you getting? Easy problem now? Okay, right. Next, example number 3. What they are given, have a look. A boat is moving with a velocity. They are given velocity of boat. How much ma? So velocity of boat with respect to water is equals to 5 kilometers per hour. So relative to water, at a time t is equals to 0, the boat passes through a piece of craft floating in water while moving in a downstream. Have a look. So here there is a piece of craft is there and it is floating in water. So at a time t is equals to 0, initially at a time t is equals to 0, this boat is moving with a speed, how much? 5 kilometer per hour, and it is moving from the crop, when it is moving in a downstream direction. Okay, floating in water while moving in a downstream. At time t is equals to 0, the boat is passes through the crop with a speed 5 kilometer per hour. Okay, sir. If it is returns back at a t1 is equals to 30 minutes, again it is returns back, it is moved to downstream and it is returns back with the same speed after t is equals to 30 minutes. T is equals to how much ma? 30 minutes. Then what we have to find? When the boat meets the rock again. When it meets the rock, have a look. It travels in this direction with this much of speed. Okay, so in a downstream direction. And after time t is equals to 30 minutes, it returns back. That means with the same velocity, it is moving in a downward stream, and with the same velocity, it moves in a upstream. Then the total time taken by the boat to meet the craft, how much ma? So A is equals to 30 minutes in downstream, total time is equals to downstream plus upstream. So it is moved 30 minutes in downstream plus 30 minutes in upstream. 30 minutes plus 30 minutes. How much ma? 1 hour. Okay. So the boat made the crop after 1 hour. Okay. So it is moves the same speed in downward stream. Okay now. So for 30 minutes. And again it meets the crop in an upward stream after 30 minutes. 30 minutes, 30 minutes. Total time taken by the boat to reach the crock again is how much? 1 hour. 30 minutes in downward stream, 30 minutes in upward stream, because it is moving with the same speed. That's it. So what is the question B they are given? The distance traveled by the boat during this time. So distance is equals to what ma? Distance is nothing but velocity into time. Okay. So what is the velocity of the boat? 5 kilometers per hour into what is the time? 1 hour. 5 into 1, 5 kilometers per hour. So the distance traveled by the boat is equals to how much? 5 kilometers. Are you getting any doubts? Easy problems one. Okay. Right. Pause the video and write the solutions. 3, 2, 1, go. Right. So this is the end of the today's lecture. So I hope that you are enjoyed this lecture. What is the concept? Motion of a boat in the line of reverse flow. So the name of concept is big, but inside the concept nothing is there. Only we have two formulas: time of upstream and the time of downstream. That's it. Right. So we will meet on our next lecture. Until then, stay tuned. And this is Rakesh signing off. Jai Hind.